Buenos días, profesora y compañeros. Nosotras vamos a presentar la determinación de azúcares reductores con el método de Somogyi. Las integrantes son Carolina Navea, Anaís Peña y Priscila Vega. Para entender mejor el método de Somogyi, hay que recordar qué son los azúcares reductores. Estos son aquellos que poseen su grupo carbonilo intacto y a través del tiempo pueden reaccionar como reductor con otras moléculas que actúan como oxidantes. Ejemplos de estos son la fructosa, glucosa y lactosa. El principio del método de Somogyi se basa en la reducción de iones de cobre, el cual es el estado de oxidación más común del cobre, a iones de yoduro de cobre mediante la reducción de azúcares. Los iones de yoduro de cobre reducen entonces un complejo de arsenomolibdato preparado mediante la reacción de molibdato de amonio y arseniato de sodio en ácido sulfúrico.
Reactivos del método. Reactivo de Somogyi: se utiliza el carbonato de sodio, bicarbonato de sodio, tetrato de sodio-potasio y sulfato de cobre. Mientras que en el reactivo de Nelson, el molibdato de amonio, arsenato de sodio y ácido sulfúrico. Instrumentos que se utilizan. Como se muestra en la imagen, los tubos de ensayo, pipeta, baño María de laboratorio y fotocolorímetro. Procedimiento. Primer paso: una solución de sulfato de cobre y un talpón alcalino se añaden por pipetas a una solución de azúcares reductores y un blanco de agua. Segundo, la solución resultante se calienta en un baño de agua hirviendo. Tercero, se añade un reactivo preparado mezclando soluciones de molibdato de amonio ácido y arsenato de sodio.
Paso 4. Después de mezclar, diluir y remezclar, la absorbancia se mide a 520 y 540 nanómetros. Paso 5. Después de restar la absorbencia del reactivo en blanco, el A250 se convierte en equivalentes de glucosa utilizando un gráfico estándar de microgramos de glucosa versus la absorbencia. Obtención de resultados. Se produce un color azul intenso y estable que se mide espectróficamente. No es una reacción estequiométrica, por lo que se debe usar una curva estándar del azúcar que está determinada.
Ventajas y desventajas del método. Puede determinar el contenido de azúcar reductor y no reductor, siendo detectado en concentraciones muy bajas de 20 a 180 miligramos por litro. Solo proporciona una medida aproximada de la concentración de azúcar. Arsenato de sodio se considera altamente tóxico.
A continuación, veremos un video demostrativo del método.
The Nelson-Somogyi method is the assay you will perform in the biochemistry lab to determine the amount of reducing sugars in a particular solution. To set up your bench for the Nelson-Somogyi method, fill a 250 ml beaker halfway with deionized water and obtain a square of single-ply cheesecloth. You should also have a hot plate at your bench space and will have a few safety tongs available for you to use. Place your cheesecloth in the beaker filled halfway with deionized water, place the beaker in the center of your hot plate, and then turn on the hot plate by dialing the power to around 60 to 75%. This setting will vary depending on the make and model of your hot plate, but essentially you want a very soft boil within 15 to 20 minutes. Seeing your water boil is a visual indicator that the temperature is at least 100 degrees Celsius, but your teaching fellows also have thermometers to verify the temperature of your water. For this video demonstration, I've only prepared the first 6 tubes used to generate the glucose standard curve with everything except the 1 ml of Nelson arsenomolybdate reagent. Note that I have labeled the tubes themselves as well as a small piece of foil used to cover the tubes. After securing the foil over each tube, gently place each individual tube in the boiling water. The cheesecloth here is to protect any tubes from hitting the bottom of the beaker too aggressively. After placing the last tube inside the beaker, set a 20-minute timer for the boiling step. You will notice that upon placing your samples into the beaker, the water will stop boiling because you've lowered the temperature with colder tubes. Resist the urge to dial up the heat on your plate when you begin heating your tubes. Instead, closely monitor the beaker and make sure that it doesn't boil too vigorously as the temperature climbs back up over the next 2 to 3 minutes. If the water is too hot and boils more aggressively, the cheesecloth at the bottom will bounce around and disrupt the tubes, which is actually not good for your experiment because the copper reagent can unnecessarily react with the air and end up skewing your results. As you can see here, I'm already 6 minutes into my boiling step, and I've already dialed it down to a 4 from the initial 6 during my preparation step. Notice the small amount of boiling at the bottom of my beaker. At the end of the 20 minutes, turn off the heat to your hot plate and exercise great care to not burn yourself, and use the safety tongs to remove your hot beaker from the plate. Take another beaker or two and fill them up halfway with warm water from the tap, and using the small tongs, transfer your assay tubes to the warm water in the same order that they were placed into the boiling beaker. Be mindful of any hot items you still might have at your bench and move them aside to prevent burns and injuries. Let your assay tubes cool for 1 minute, and then you can transfer them to a tube rack with your bare hands. Remove the foil caps to your tubes and add 1 ml of the Nelson or cinnamalibdate reagent, but be careful to not add the reagent too quickly, as tubes that contain considerable amount of reducing sugar will bubble up. During the 5-minute incubation step, mix the tubes by either shaking them or using a vortex to gently homogenize the sample. Here I'm not showing the addition of water in this demonstration, but after adding the 5 milliliters of water, mix your samples by taking a piece of parafilm, place on the top of the tube and secure with your thumb, and gently invert 4 to 5 times. Let your tube stand for a minimum of 30 minutes for the final incubation step, and use your benchtop spectrophotometer to read the absorbance of your samples. Depending on the amount of reducing sugar in your sample, the tubes will vary in color from a yellow-green to a teal to a blue-green color as the concentration of reducing sugar increases accordingly.
Bibliografía. Muchas gracias por su atención.